Let's dive in on Uniswap V4. So I think the first question to answer about Uniswap V4 is, what is Uniswap V4, right? For those of you who aren't, who don't like to look at code, don't worry, I don't have very many slides like this. But I wanted to start off by clarifying at a technical level how Uniswap V4 is set up, because it's actually, in some sense, at a conceptual level, less complicated than you might imagine. And so, for the people who are comfortable with code, I wanted to screenshot this part of the code, which I think is, in some sense, the heart of the definition of what's happening in Uniswap V4. I will explain this without code in a moment, so don't worry about it if you're not, if you don't like looking at this. One way to, if you take a step back and think about what we're talking about, what is a decentralized exchange? Well, it's a bunch of what we call liquidity pools, right? So there are a bunch of, each of these liquidity pools really are sort of asset swap markets where you can go and conduct spot swaps of one asset versus another. And so in Uniswap V2, you might have an Ether USDC market, you might have an Ether wrap Bitcoin market, a USDC wrap Bitcoin market, et cetera, et cetera. But you can think about, when you want to think about decentralized exchanges, I think you first have to think about what does a liquidity pool within that decentralized exchange look like? And so what I'm actually showing you here is what a liquidity pool in Uniswap V4 looks like. And again, I'll go through this without the code in a moment, but what I actually want you to get from this slide is there are only 5 things in the definition of a liquidity pool in Uniswap V4. 1, 2, 3, 4, 5. Okay, so we talk about this idea that it's going to allow a lot of customization, et cetera, and that's true. But that doesn't actually complicate sort of the 30,000-foot view definition of a liquidity pool. There are only 5 things that define it. Now, some of you looking closely at the slide might notice the last thing says hooks. And I will spend most of my time talking about that because it turns out that is the novelty here. But before that, I want to clarify, again, this point that I alluded to a moment ago, which is that the point of departure for Uniswap V4 is Uniswap V3. And if I want to be more precise about that, here I say a liquidity pool in Uniswap V4 is defined by 5 things. Well, it turns out a liquidity pool in Uniswap V3 is defined by 4 of the 5 things. And a liquidity pool in Uniswap V2 is defined by 3 of the 4 things that it's defined by in V3, and of the 5 things that it's defined by in V4. So before I get to this last one, hooks, which is the new thing, the 5th thing, I want to do a little bit of recap without the math that Andreas had, more from a conceptual perspective about how we get to 5 things. And then I'll focus on that 5th thing, which again is the novelty of Uniswap V4. And again, please ask questions at any point in time if anything occurs to mind. Okay, so what is a liquidity pool in Uniswap V2? Well, again, I think it's useful to conceptualize liquidity pools as asset swap markets where we do spot swaps, right? And the spot swaps in Uniswap's world are in some sense simple because there's only 2 assets that you're swapping one for the other, right? And so if you think about, well, what's the simplest way to define this kind of a liquidity pool? Well, if you're going to be doing spot swaps of one asset versus another, you have to tell me what the 2 assets are to define the pool, right? And so 2 of the 3 things that define V2, which are part of the 5 things that define a pool in V4, are the 2 assets. And in the code, they're referred to as currency 0 and currency 1, which I'm not a big fan of using the word currency to describe these assets. But nonetheless, I'm going to use the language that is in the code here. So if you see currency 0 and currency 1, I'm just saying that you have to tell me what is the first asset and what is the second asset that I'm allowed to swap against the other, right? So you're going to be paying one in one of them and receiving in the other one. And there's only 2 things you can do. You can pay currency 0 to receive currency 1, or you can pay currency 1 to receive currency 0. That's all that happens in the particular pool, right? So that's already 2 out of the 3. What's the third one? Well, as was alluded to in the last talk, if you're going to have trading in these venues, you're going to need fees. And so in V2, for instance, there was a fee level that was 30 basis points, right? But more generally, the point is if you're going to define the simplest version of this asset swap market, you got to tell me what are the assets I'm swapping against each other. That's already 2 things out of 5. And then you got to tell me what the fees that the traders are going to be paying. What is that? Okay, so V2 has 3 things, and these 3 things are in V3 and in V4. But so Now, Andreas spent a fair amount of time on it, but I'm going to just remind you here, what is the thing that V3 added to V2? So V3, of course, is going to keep the idea that you got to tell me what the two assets are that you're swapping, and it's going to keep the fee. It did allow for more freedom on the fee. It wasn't hard coded at 30, although there are only 4 values that it does take on. But nonetheless, at a conceptual point, there's still a fee level that traders have to pay that you have to sort of specify upfront. And what V3 sort of augmented, the dimension where V3 sort of augmented V2 was this idea of tick spacing. Okay. Now, I'm going to give you a graphical view of this as opposed to the math view that Andreas was giving you. This is, I think, in my mind, sort of the easiest way to think about tick spacing. So you have a given asset swap market. Let's say, for simplicity, currency 0 is Ether and currency 1 is USDC. So you think about the range of prices that are possible for Ether versus USDC. That's the positive real line. Well, what V3 is going to do is it's going to partition the positive real line, right? So for instance, here I have an interval from 2400 to 2425, an interval from 2425 to 2450, 2450 to 2475, and it goes up and up all the way. And the point was V3 was saying, look, when you provide your liquidity, we're going to ask you, where do you want to deposit your liquidity? Which intervals do you want to deposit your liquidity? Whereas in V2, when you provided liquidity, you didn't say anything about the pricing. Your liquidity was essentially spread uniformly across all positive prices. In V3, we say, no, 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 you have to tell me, which intervals, or rather, we'll give you the ability to concentrate your liquidity into smaller and smaller intervals. And one sort of way you can think about this is that, if you make these intervals very, very large, it starts to look like V2, right? Because you no longer really have the ability to concentrate liquidity because you can't get inside these intervals. These intervals essentially define the minimum concentration that you can achieve. And so if they're very large, then you're sort of stuck spreading your liquidity. And on the flip side, if you make these intervals basically 0, then you're actually, in some sense, closer to a limit order book, because in limit order books, of course, you don't specify intervals, you specify actual literal prices. And if these interval sizes go to 0, then you're back to sort of specifying prices, although it's two-way as opposed to a limit order book. Okay, so that's, again, probably review and sort of boilerplate, but that's V2 and V3. And the point that I'm making is that already gets you 4 things in the definition of a liquidity pool. And so that ends up being the point of departure for V4. So what does V4 add? Well, it adds this thing called a hook, okay? Now, that's all well and good. I'm sure most people in the room have already heard this idea, but you're probably wondering, well, what on earth actually is a hook? So maybe let's get to that. So ultimately, a hook is just computer code, or if you like in jargon speak here, a smart contract. A hook is a smart contract. And when people think about it this way, okay, so first of all, I think you can already start to feel why people refer to this as allowing for a lot of customization, right? Because if I say, hey, just write me a chunk of code, well, you could write a lot of things in there, right? So there is, in that sense, a certain level of freedom that didn't exist in the prior versions. Like if you think about V3's freedom, oh, I get to pick a number that corresponds to the tick spacing. I mean, that's a very sort of that's a very specific action space. Whereas here it's like, oh well, you get to write some code. But the point is, I think we have to take a step back and sort of think about what we're really talking about here. So the code is not fully arbitrary. In fact, even the code that you're writing is not fully arbitrary. And so the specific thing I want to point to is the last line I have here, right? So the hook actually has to implement a standardization. So you cannot write an arbitrary smart contract and call that your hook contract. It must conform to a certain standardization. Now, I don't have too many slides like this, but I do have a few again. So this is the standardization that it has to conform to, right? In more technical speak, there's an interface called iHooks. And by the way, if you were looking closely at the other slide where I had some code, the hooks value, its type is iHooks. What does that mean? That means, yes, you get to write a smart contract, which we'll call hooks, but it has to implement a particular standardization, or if you like, a particular interface, which is the iHooks interface. And so you can't just do anything you want in this smart contract. You have to implement this interface. Now, what does that exactly mean to implement an interface? Well, basically, an interface is going to say, look, you have to include these functions in whatever code you write. You have to tell me what happens in these particular cases. Now, I don't expect everybody to sort of read carefully through this slide, but I was hoping people would look at it close enough to notice a very distinct pattern in the functions that you are supposed to write when you are writing a hook contract. Okay, so if you look, basically every 2 lines, you see a new function, and they have a very predictable pattern in their naming convention, right? So the first one is called before initialize. Second one is called after initialize. The third one is called before add liquidity. The fourth one is called after add liquidity. Then you have before remove liquidity, after remove liquidity, and then before swap. And I ran out of space on my slide, but I'm presuming you could probably guess that the next one would be after swap, right? So there is a very predictable pattern that arises here in terms of what you actually have to specify.
It's an ignorant question. Are you going to tell us what is the purpose of hooks? Why do we have them? What do they do for us?
So I am going to try to engage that, but I think that's remember, I'm not at Uniswap Labs, so I can't speak from what they were thinking, and there's also an extent to which I can interpret your question philosophically. But I'm going to try to take it more from, I think you probably have
economics.
Yeah. So I'm going to try to go in that direction, but I think it's a very big question, and so it's a little bit too much to get to in this talk, but I will try to eventually get there.
But what does it really add?
Yeah. So the design space is very large. And so I'm going to show you certain things you can do. It's not clear to me those are the best things you want to do. And that's what I'm saying. Actually, I think this is a point of research inquiry to think about, given the design space, what are the best things to do? So I'm going to give you a little bit concreteness and things you can do, but I'm not saying they're the best things. And it's because I think it's a pretty deep question, actually. But Bruno, maybe coming back to it, I'm hoping that you'll have a better sense of the action space so that you can tell me what are the best things to do. Okay? But I haven't gotten there yet either. Okay, so let me sort of make this state this in a more conceptual way. So basically, if you think about even decentralized exchanges as they already exist, there are certain sort of important actions that happen. For instance, swapping or trading is one of them, right? Liquidity provision is another one of them. And I think one way to conceptualize a hook is it's basically saying, like, look, we're going to allow you to do something before the important action and something after the important action. And you can choose what that is, okay? So that's why you have that before-after structure. They're already sort of, let's call it important functions that need to happen that we're already familiar with, right? And it's going to give you a certain amount of customization in terms of what should happen directly before an important action or directly after an important action, which is exactly why you see all these before and afters. And so, I think one of the actions that as economists we focus on a lot is swapping. And so there is, of course, a before swap and an after swap, just as a concrete example of that. And in some sense, if you're wondering why they're called hooks in the first place, well, these functions in some sense hook in before and after the routine operation that you're already familiar with. And so I have one last slide that has actual code on it. And it's just to make concrete that point. So essentially, if you end up doing a swap at Uniswap, it's eventually going to hit this code, which is this function called swap. And you see this red part in the middle calls this other function, which is called in this case underscore swap. So it's kind of an internal swapping function. That function basically does what V3 does when you swap at V3, okay? You can think of that as like V3 swap, okay? What you have the freedom to do is to do something before that happens and to do something after that happens, if you so choose to use that freedom. So the green stuff that I have here, the first green one is calling before swap, and the last green one is calling after swap. And so it's saying, hey, you want to change something right before we get into this swap function? You can do that. You want to do something right after we exit it? You can do that too. And just to give a very sort of simple example of this that I'll come to later also, which again, I don't think is really an important example, but it's one that people do think of, is stuff like dynamic fees. You could implement it basically by changing the fee level in the before swap before you hit the actual swap. Yeah.
Who provides the hooks? Is it the liquidity providers, the traders, or the...
Well, it's a permissionless system, right? So you can write a hook contract. In fact, Shin, Brad, and I wrote a hook contract just for the hell of it.
So if many people provide the hooks, then all of them will be called upon when the...
No, so okay, so here's the way you should think about it.
use them.
No, so when you decide to launch a pool, you have to specify a hook. You could choose to use somebody else's hook. You could choose to write your own hook. So for instance, you could imagine that there is a hook written to do a certain functional thing that you care about, let's say dynamic fees. And you go like, okay, fine. I want to launch a liquidity pool that has that functionality. Let me just attach this hook into my pool when I do it.
Just to clarify on this, so so I understand this before and after, but would this apply to all swaps that go through this pool, or is it to this particular one? And then you can change, like, for the next swap, like there would be another hook applied. So, or this would be
No. So every pool has exactly one hook.
one hook. So
Yes.
it means that to implement two different hooks, you would need two different pools.
So I'm not sure that's so let me put it differently. You could make the logic inside this before swap function very conditional. So the idea that, like, I think what you're getting at is like, why can't I attach two hooks to a pool? Well, it's not clear to me the action space is any larger because you have a fair amount of freedom in terms of writing these functions in the first place. Does that make any sense?
Yes, sure. Yeah.
Okay.
I can ask later.
Okay. I mean, well, you're just your
Just
call.
continuing with Bruno's question. So I
Yeah.
was discussing this with the really TradFi trader. He was telling me like the same, the similarity. Can we call hooks as like arbitrary message parsing protocol, just like a fix in trading, right? Because it just tries to communicate with a trading engine, right?
I mean, there are implications to things like terms of trade and so on. So I'm not exactly sure that I would frame it that way, but it's also possible I'm not fully understanding the way you're thinking about it. So I'll provide I think I'll provide a little more context in the way that I'm thinking about the action space here. And I wouldn't frame it that way, but again, that may be me misinterpreting the way you're thinking about it here. Maybe I'll take Jason and then I'll keep going because we are behind on time and we can talk after for the other questions. Jason?
Could you elaborate on what's the role of the key and the pull key stuff here? Because I don't see it discussed. But
I mean, I don't think it's going to illuminate anything. So actually, it's going into something called a hook library. There's another file. So yeah, I don't think that's going to illuminate anything for anybody here at this point. But you and I can talk offline. Okay. So maybe let me keep going because I haven't provided, frankly, a lot in terms of understanding the action space here. Right now, I'm just trying to get you to understand that you have a certain amount of customization that you can add before and after important operations. But okay, this is getting more into maybe the high level context and maybe starting to get to what you can actually do with these things. So the first thing I want to say is that there are some obvious limitations here, right? So it is ultimately just code. Right. So for instance, it can't steal a car, right? Like, I mean, you know what I mean? Like, it's not literally arbitrary. Like it can't, it doesn't, it's still a digital system. It can't suddenly start accessing physical things and doing things that you wouldn't normally expect these systems to do. So one way to think about it is that what the hook is primarily going to do is it's going to like specify and execute the net transfers. And when I'm referring to net transfers, what I want you to think about is stuff like terms of trade, right? Trading is a transfer where I give you one thing and I get something else. That's what a spot swap is. So it can sort of adjust the terms of those things, right? Liquidity provision too, right? There maybe I'm transferring some assets in or I'm receiving some assets out. This can basically play with the sort of with the quantitative dimension of that. Okay. Now, of course, again, usual caveats apply. Even in the digital space, when we're talking about net transfers of digital assets, the system has to understand the asset, right? So in particular, the net transfers we're talking about are of assets settled on the blockchain, right? And also kind of maybe getting into the dimension of like how much fraud could happen in this setting. Just as in something like V2 and V3, you are going to have to approve the funds coming out of your wallet. It's not like this is a magic smart contract that can suddenly steal from you. Now, if you click the button that approves an arbitrarily large amount of transfer out of your wallet of the ERC20, as many people do, then yes, okay, maybe you could take the entire thing, but that's because you approved it, right? If you don't approve it, it doesn't magically have the ability to steal from you, right? So again, I don't know if this is the right framing, but right now I think of it more so as a way to affect terms of trade, be it swapping or liquidity provision. But maybe let me add a little bit to it because when you think about the action space in that sense, you might feel like it's still quite large to the point that, for instance, from an economic perspective, you might imagine something like multiple equilibria arising just because of how, how large the space is. But one of the things about whenever you have multiple equilibria is you have to think about selection of equilibria. And I think, from a practical perspective, one of the answers ends up being something that can be quite boring from an academic perspective, is sort of a default option that people tend to rely on, that they tend to coordinate on. And this comes back to this point about V4 as an extension to V3, V3 being the point of departure, right? So in principle, when you specify that hook contract, you could specify everything empty, but then you basically have V3. So when you think about people doing really inventive stuff, you're basically asking them to decide, oh, let me redo the entire functionality of V3 by myself. And yes, it could happen. And I'll even give an example where really the guts of V3 are completely sort of overhauled. But I don't think most people are going to start there, right? There's certainly some people who are being very inventive, and you're going to hear from a couple of them later today. But my guess is most people, when they start playing with these things, are basically going to preserve a lot of the core functionality of V3 and then layer stuff on it. So for instance, dynamic fees is a really obvious example. If I tell you they're dynamic fees and I tell you how the fee is changing, I actually haven't told you everything. There's a question about exactly how that fee plugs into other things, exactly how, for example, price impacts work and so on. So normally when people are talking about stuff like dynamic fees, what they really mean in this context is we will literally change what would have otherwise been a hard-coded fee and then run V3. Right. But that's my point also in terms of you think about the economic implications. I do think there is some merit, there's some significance to thinking about sort of V3 as point of departure and V3 almost as like the coordinating thing that people are likely to do and then just sort of add to. Yeah, question in the back?
I guess this is sort of like under action space. So let's say all these pools are independent. Let's say there's a whole bunch of them. So can I put in the hook? Is that I know they're distributed, but are they aware of the other pool? Because if you can interrogate the other pool, then you can bring back, pricing capabilities and taking advantage of different markets into your own hook.
So awareness is always a tricky concept when we're talking about computer code, but let me see if I can get to the heart of what you're getting at. So you could make the contract aware of other pools in the following sense. You could define an attribute in that contract that, for instance, has information about every pool that deploys with the hook attached to it, right? So you could put that in. But again, one of the things I'm trying to emphasize here is you could also just basically write an empty contract with empty function bodies, right? And that's kind of like the starting point, right? So whatever rich functionality you're thinking of, you have to take care of everything to the point that everything compiles, right? Like any tweak you make has to kind of like trickle all the way through. Otherwise, the thing's going to blow up, right? I mean, it's not going to compile and nothing's going to work. Yeah.
I have another question on the how arbitrary a hook code can be. So
Yep.
I think for the example you just mentioned, if you want to make your dynamic fees based on like the underlying token pair price or volatility, can you have like access to oracles or stuff like that in the hook code?
Yes, absolutely. But I mean, again, with the usual caveats. So in fact, I think the presentations you're going to see later today do rely, at least one of them does rely on on an oracle. But again, that doesn't resolve the oracle problem, right? So
You can use it in hooks.
yes. I mean, again, it's a smart contract. So you can do all the usual stuff that you can do with smart contracts, but you're also limited in the same ways that other smart contracts are limited. And there's this additional aspect where you're implementing a very specific interface, right? But okay, let me maybe keep going here. So I just now alluded to this point about, well, look, it can't just take all of your funds if, for instance, you don't approve your wallet giving it access to those funds. Now, that is true, but there's in some sense a more subtle form of, let's say, theft that can occur. And part of what I want to highlight is like, so you might sort of think in a vacuum something like a good design of Uniswap V4 would fully preclude any sort of theft. But part of the point I want to make is if you think about sort of something that would allow for arbitrary terms of trade, then it kind of has to allow for something that is essentially indistinguishable from theft. And that means that this is also part of the design space here in Uniswap V4. So for instance, here I'm asking, can a hook steal from a trader? Well, what exactly does stealing mean? If you say, hey, I want to buy Ether using USDC, so I want to do a spot swap, right? Where you're saying you want to do a spot swap where you pay USDC and receive Ether. Well, if you say that the AMM you're facing has to have arbitrary discretion about setting prices, what if the AMM tells you the price is infinity? How much Ether do you get for your USDC if the price is infinite? You get nothing, right? So in principle, if you want to allow for totally arbitrary pricing, you basically have to allow for situations where, the user isn't actually getting very much for their swap. And this sort of introduces another complexity, which I think Uniswap will have to deal with in terms of like their router and incorporating all of these pools. It is not the easiest thing in the world to figure out whether the pool is sort of behaving rightly by their customers or not. Because if you're going to allow, again, for arbitrary pricing, which I think arbitrary terms of trade essentially are on the table in Uniswap V4, then you are allowing for situations where traders end up in, very regrettable circumstances, particularly if they don't know what's actually happening in terms of the pricing mechanics. Yes.
Yeah, I have one clarification question.
Yeah.
Can the hook detect who's calling this hook in terms of who's using? Because in that sense, I think there could be potential for price discrimination or price differentiation for different users.
I mean, so again, this is sort of up to the usual answer for smart contracts, right? So it can like access msg.sender, right? So it can know pseudonymous identities, right? Things like that. And I just mean this in the sense that the code can make references to things like whoever has created the transaction, right? But that's not really new relative to any other smart contract. Let me also do another sort of version of the same thing on the liquidity provision side, right? So can a liquidity provider deposit liquidity and essentially get nothing back eventually when they want to withdraw? Well, again, in some sense, this is part of the design. It's not a bug, it's a feature, right? And what I mean here is, for instance, you might have a rule at a liquidity pool that says, look, if you don't provide your liquidity for long enough, I'm not going to give you anything, or I'm going to give you a very small share of what you would have gotten otherwise, right? And so you imagine a situation then when let's say a liquidity provider has to prematurely withdraw owing to some liquidity shock outside. Well, in that case, they're not going to get very much when they pull out. But again, that's part of the design space, right? So the design space in that sense is very rich. And again, I'm currently thinking of it more as a generalized way of being able to specify the net transfers, being able to specify the terms of trade, and being able to specify sort of the transfers that liquidity providers will face when they both provide liquidity and when they remove liquidity. But part of my point here is if you think of it that way, then lots of things can happen that we might have different normative thoughts about, because they can, like, essentially a routine thing that you might think of where you want to incentivize long run liquidity provision could end up looking something like not ideal for the liquidity providers. Any questions? Yeah.
The way it's currently like, so, okay, I see there is these hooks allow for more or less arbitrary customization of pool. Yeah, so, and then the first question that occurs to me is, okay, so does it mean that liquidity gets like fragmented across all of these pools? I mean, the Uniswap must have thought of that, right? So.
Well, again, so I can't speak for Uniswap, but I will say there is an aspect to which routers sort of are supposed to help with that, right? So it's not like people are expecting you to sort of select, I'm going to trade with this pool or that pool or that pool. Right. So yeah. So it's not, I mean, I think it's hard for me to make a statement about whether, in equilibrium, you're gonna have liquidity fragmentation or not, and so on. But it's, I guess, another way of saying what I want to say here is that I do think they're thinking about this, and so I'm not sure it's as bad as people would think it might be, obviously. And another thing, of course, is like, look, if you look at the set of liquidity pools that exist for Uniswap V3, just as that, right? I don't know that a lot of people are trading at ETH USDC with 100 basis point fees, right? So you can create as many ridiculous pools as you like. That doesn't mean people are actually going to trade at it. So I do think they're thinking about it, but I shouldn't speak for them. And it's not clear to me it's such a big issue in that sense. Yeah.
But this whole point, like, also, so just sorry to follow, like, of the dynamic theme.
Yeah.
Yes, I see the point, but would this mean that I mean, currently there are two liquid pools, yeah, like of ETH USDC 0.
There are four. No, that's the thing. Yeah.
Four, trading just happens a lot, like mostly in pools. So, and then the dynamic fee would be like the goal to bring those two pools together. Or like, would there still be some separation, for different clientele.
So again, I can't, I don't, as a theorist, I don't like to theorize too much without a model. So I don't want to say too much in that direction. I will say just observationally, I do think there is even amongst like this idea that, there are two major pools, there's been a bit of convergence towards one of the pools sort of suddenly dominating the other. So in the case that you would have dynamic fees, I don't see why if the dynamic fees are specifically set up carefully and like, they're going to capture things like when volatility is higher, the fees go up, right, to address adverse selection and so on. It's not clear to me that all of liquidity doesn't go there, right? So answering it sort of formally is difficult. It would require, some study, and maybe somebody here would like to take a shot at that through the research funding proposal that we started off with. But again, I think this is something that Uniswap is aware of, if I can speak for them, and I think it's something that that is not as dire as you might initially think, precisely because most liquidity pools don't get very much liquidity in the first place, and so yeah, I'm not sure it's that fundamental. Fabian, you have a.
I think as soon as you introduce custom code of design space, the router will not work anymore. Like there's some manual selection. So I would suppose there is certainly fragmentation, but most of the liquidity will still go to the original pools.
Like the V2 and V3 pools, or when you say original, what do you mean?
We don't have the hooks just give you more flexibility.
Yeah.
By default, I don't think a router can just select a pool with a hook with custom code, because the router itself will not know what happens with it.
No. So that's an engineering question. Is like, can the router properly assess the cost structure? But of course, one of the most obvious, maybe trivial points is that if there's no liquidity at all pools except for one, then you're going to get this trivial outcome where all the trading happens at one pool, because if the liquidity is zero at this other pool, it's going to have infinite price impacts, right? So nobody wants to trade at a pool with zero liquidity, and that allows you to sustain an equilibrium where you only have one pool that has liquidity, right? So yes, there are engineering challenges associated with even figuring out what cost structures are going to look like exactly in this space. I will defer to the Uniswap Labs people about how they're thinking about that, though. If I can maybe move on, because I think I'm not doing a great job on time, and we already started a little bit late. So let me maybe quickly give you a little bit of an overview, and then I'll give you just a couple examples to maybe help a little bit more with the action space. So there are basically 5 core functions that happen at these liquidity pools. One is initialize, which is the creation of the pool. The next 3, I think, are the most important for economists to think about, which we already think about this a lot in the existing literature. So one is swapping, right? That's trading. And then the next 2 have to do with the liquidity provision side of things. So there's add liquidity and remove liquidity. There is a 5th function called donate. I don't know if that's of first order importance as from a perspective of researchers. But the point is, each of these, you have the ability to write a before function and an after function. And so basically, technically speaking, every hook actually has to specify 10 functions. I will provide a caveat here because some people don't like it when I frame it this way, because most people writing hooks don't actually write all 10 functions, but that's because they usually inherit another smart contract, which is already provided, called base hook, that has basically empty versions of these functions, essentially, or they like versions that just revert. But the point is, technically speaking, for your hook to be well defined, you have to specify all 10 of these things. You can inherit, again, from base hook in a way that nothing will actually happen. And so essentially you have, an empty, you essentially have no code where maybe one of these operations are. But that is in some sense like the space to write, is that you can write up to these 10 functions, okay? Now there is another piece there, which is there are a bunch of flags which essentially tell the hook whether or not it's affecting the terms of trade at certain points in time. And I'll clarify that a bit more in a couple of slides with a concrete example, but this actually gets to some of the engineering questions, I think, right? So these flags are going to be useful for the engineers to tell whether something bad can happen or not. So these specifically tell tell you whether there is a transfer sort of happening over and above the usual transfers. Now, given that something is happening, it doesn't tell you exactly what that's going to be. But for example, if all these flags I'm showing you on the screen are false, then it tells you that there's a lot less room for bad things to happen. So So one way to think about, again, the design, well, this is not really, one way to think about more from a mechanical perspective, what the designer can do is that there are 5 before actions you can do, 5 after actions you can do. And when I say actions, you mean you specify the entire function body. Again, I would say the important ones are swapping after liquidity, swapping, adding liquidity, and removing liquidity. Those are probably the ones that are going to get the most study from economists. And then there's sort of 4 flags that essentially tell you whether some of these functions are actually affecting terms of trade, affecting actual transfers. Now that might seem a bit abstract, so maybe let me just sort of conclude with a couple of examples, which are examples that I think a lot of people think of. One I already alluded to, dynamic fees. So mechanically, how do dynamic fees work? Well, basically, you would adjust the fee level in before swap. And if that's the only thing you do, then what it's going to do is it's going to take your new fee level and it's going to basically run V3 pricing on it. Because again, the core code of V4 actually is the V3 code. It's just got stuff around it, which is what you can customize. The second example, I think, is maybe more telling a little bit about kind of what the complexity that is possible realistically from V4 is. So, of course, one of the early ideas, again, that comes to mind for a lot of people is like, what if we make the AMM structure very different? What if we choose a totally different AMM structure? Now, that actually is quite complicated, I think, in practice, unless you're doing something very simple like, a linear bonding curve. Because the way you would have to do that basically is you have to short circuit the core functionality. Because remember, the core functionality is V3 functionality, and there's a lot that goes into that. So actually, the way you do this is you basically do all of your pricing in the before swap function, which means you are now responsible for setting up basically all the AMM math, which is easy if you have a linear bonding curve, which is the classical example people show. A lot harder if you really want to think about your own sophisticated AMM structure. Now, one question is, okay, great. So I set up my own structure in before swap. How do I stop V3 from, going and doing what it's normally going to do thereafter? This is actually where those return deltas come from. Basically, you can tell it that the whole trade has been done. And so when it hits the sort of V3 code, it's going to treat the trading volume as though it's 0. This is why you need the return delta, because the return delta is where you can say like, okay, some action actually happened here up front. And so if you say basically the whole trade got done in before swap, now you're asking V3 to do a trade with 0 volume, it's going to basically just go, it's going to do nothing. And that's how you would implement sort of an arbitrary AMM structure. I do have some more examples, but I could imagine it could get dull if I just sort of walk through example by example, and we are behind on time, as I can see from Andreas nodding at me. So with that, I'll actually conclude, and I can take questions, of course, offline. Thank you.